The area trapped under any normal curve is 1 or 100% of the population. This implies that if we added up all the area from z equals like -10 to z equals 10 standard deviations either way, we'd get 100% of the population under the curve. The Texas Instruments graphing calculators allow us to quickly determine proportions of populations in certain intervals by using the normal CDF function. So we are going to the golden calculator. Golden calculator. Yeah, right on. There you go. That's it. Golden calculator got a little attitude. Take you to the dentist. Give you a root canal. Anyway, let's go to doing normal CDF on the calculator. So we're going to go second distribution right above vars. We're going to choose option 2, normal CDF. We need the lower and the upper end of the interval for which we want the area under the curve. So we're going from -1.58 on the left end of the x-axis, and we're going up to 0.61 as the furthest to the right we're going. And by default, the calculator is set with the standard normal distribution, mean of 0 and standard deviation of 1. So now we just go down to paste and hit enter. Now if you have an older calculator, this is what you need to type in. You got to type in the low end of the interval with the comma in between it. The comma is a button right above the 7. And then the upper end of the interval, 0.61, and then the mean and the standard deviation, commas between each. And there we go. There's our answer. That's the proportion that's in that interval. Returning to the weights of bears, which are normally distributed with a mean of 660 pounds and standard deviation of 40 pounds, determine the proportion of bears weighing from 700 to 750 pounds. So now we again go to normal CDF, so second distribution, option 2, and now we're going to type in the weight interval for which we want the area under the curve between them, so that would be 700 on the low end and 750 on the high end. Now we have to give it the mean specific to this normal distribution and the standard deviation for these weights. Again, just hit paste, hit it again, and boom. About 15% of bears are in that weight interval. The scoring guidelines for AP free response questions like this can fluctuate over time. The most concise way to show understanding and get full points is to write this, and then just utilize the calculator to get the correct answer and add it to the work. This is what I train my students to do. If instead you want to show the work via the calculator, you need to write this and you need to identify the mean and standard deviation in context. So add this. Then add the proportion answer from the calculator, and in playing the game of maximizing points on the AP exam, the second approach runs the risk of slightly misstating something and losing points. It's why I encourage the more concise answers. 2 more problems. Find the probability of a randomly selected bear weighing more than 630 pounds. Well, now what we need to do is again go second distribution, option 2, but we need more than 630. So what we do is we type in 630 as the low end of the interval, but the upper end, there is no boundary. We're just going to go way to a big amount. So type in something that's many, many more standard deviations than 3 above the mean. So we'll type in a bear weight of type in a weight like 10,000 pounds. And yeah, apparently Yogi had a few too many salmon. He made a boo-boo. But let's go to paste, and boom, there. That's the proportion of bears that weigh above 630 pounds. Suppose we're asked to find the probability of randomly selecting a bear who weighs less than 575 pounds. Well, now again, second distribution, option 2 for normal CDF. Well, now it's the lower end that doesn't really have a bound. We're going way to the left. So just type in a ridiculously low number. You could even make it a negative weight. Like, I don't know, the bear's floating like it's a Macy's Day Parade or something. And 575. Would be the upper end, so the interval really from 575 and way below, and then just go down to paste, and boom, there it is. Less than 2% of bears weigh below 575 pounds.